So welcome to this video, and in this tutorial we'll be talking about the right quantity. And the goal of the procurement department in this case is to make sure we do not have too little, in that we have shortages, neither do we have too much, in that we have surpluses. The idea behind it is to match supply and demand and be able to find that sweet spot which we call equilibrium. Because anytime you hold inventory in your organization, it is a cost to you. Anytime you lose a customer because you do not have the items in your organization, again, it is a cost to you. So how do you determine the equilibrium or the sweet spot? Now, you have to think of the supply chain systems in this case, and we'll break them down all the way till we find the forecasting techniques. Now, we said that there are two main types of supply chain structures. We said you can have a make-to-stock system, and we said you can also have a make-to-order system. In this section here, we said that nothing happens in this section until the customer orders. But in this section, the production of the product starts, the item is stocked and supplied to the distributor gives to the retailer gives it to the customer. And we further said that there are some products, number one, and two, the demand is certain. For example, Blue Band is a functional product. We need it on a daily basis. Clothes are functional products. We need them on a daily basis. The demand for these products is certain. But whenever we're talking about MTU, we say if the depreciation of the product is very, very high, then you do not produce and stock. If the product in question is not functional, in that it is an innovative product, we do not stock those items. If the demand is not certain, we do not stock. And we said further that the equilibrium between these two is what we call a configure-to-order system. For example, what Pizza Inn is using. Now, all these systems here are trying to find that equilibrium and balance between demand and supply. And it's a very tricky science in itself. So, don't forget, configure-to-order is where the customer gets to configure what they want, but we only stock the raw materials. And this we said, when you walk into a Pizza Hut, the raw materials for the final pizza, which is Hawaiian, are already there. What is not done is the final products for the Hawaiian, mid-deluxe, or whatever pizza they have has not started yet, waiting for the order. So they are able to balance those two. So, in a situ, they're stocking the raw materials, but waiting for the order. So, in that case, you always want to ask yourself, how do you determine the sweet spot or the equilibrium for the materials that you need? Now, think of it this way. If this is organization XYZ, and we start off at quantity 1 here, and this is period over here, this stands for period. Then as time goes on, we use those materials all the way until we get to 0. Then we reorder again over here, back to quantity 1. Then we go back to 0 again. Then we order again, back to quantity 1. Then the same thing happens. We go to 0. Then quantity 1, back again. So in between point 1 and point 2 is what you call the lead time. That's the first thing. The second thing is, the longer the lead time, the more you cannot risk going to 0. So another system would look something like this. This is organization A, B, C. They start at quantity 1, they go all the way to quantity 2, not 0. They go all the way to quantity 2, reorder, then go back to quantity 2, reorder, go back to quantity 2, reorder. This here is what we call the safety stock. Therefore, in this system, we do not have the safety stock. In this system, we have the safety stock. And the reason why the safety stock is there is to make sure that it takes into consideration the lead time issues that could arise in this section. So one of the things that you need to consider when determining how much to produce in an MTS system is the lead time. The second thing is the quantity or the demand that you'll be calling optimal in this section. Now, when forecasting, we say that there are several methods that you can use. The first one is a fixed period system. The second one is what we call a fixed quantity system. A fixed period system and a fixed quantity system. A fixed period system, this is where you are ordering after a predetermined period of time. For example, after 30 days, you reorder. After 90 days, you reorder. That's what you call a fixed period system. A fixed quantity system is you reorder the same quantity each and every time. In the first one here, you have what you call a fixed period system after time t. The second one has to do with quantity. So, if you are going to use a fixed quantity system, this is what you call the Eoq system, is an example of the fixed quantity system. And it says that there is an economic order quantity that any organization can order. There is an economic order quantity, and this quantity is arrived at by balancing the ordering costs and the handling costs. So if graphically I was to represent this model, Eoq model, it would look something like this. You have the handling costs on this section, and what this graph shows is that as the quantity increases, the handling cost per unit increases. Now, the other one is what you call the ordering cost, and it goes in the opposite direction. Ordering costs. And in the ordering costs, the larger your quantity of order, the lesser your ordering cost per unit. Again, we go back to the economies of scale. I'll repeat, the handling cost, as the quantity increases in this direction, the handling cost per unit increases. The ordering cost, as the quantity increases, the ordering cost per unit decreases because of bulk buying. Therefore, the total costs are calculated by handling costs plus the ordering costs. But we never want to find the equilibrium. The equilibrium is found at this point over here. Where we say, if you differentiate the total cost curve, which is curve 1, which I've indicated here, you will arrive at the Eoq. Now, since there's a unit on stores management and stores control, we do not need to go into details for that, although it's in the notes. But bear in mind this for the sake of the basics, that we arrive at the economic order quantity by balancing out the handling costs vis-a-vis the ordering costs. Now, the ordering costs are calculated by the demand divided by the order that we order every time times the cost per order. So, bearing in mind the EOQ model is arrived at this way, and bearing in mind the aspects of the MTS system that are this way, there are other issues that come up in forecasting, because this is one method of forecasting. This here is one method of forecasting. But there is the other method, which is called the moving average method. And in the moving average method, there are two types of methods. You have the first one, which is the simple moving average method, and then there is the exponential moving average method. Now, in the simple, it takes the average. For example, if you're looking at the data and you say you take the monthly average, so if we move from month 1 plus month 2 plus month 3 plus month 4, then the average here becomes the most optimal next order quantity. In other words, this quarter 1, month 1 plus month 2 plus month 3 plus month 4 will become the average. But in the exponential, it updates itself, so that if you are going to month 5, we will remove month 1, so that we have month 2, month 3, month 4, and month 5. If we are looking at the quarter, 4 months chunk. If we're looking at the quarter, I'll repeat, in the first one, it does not remove the oldest month in the chunk. But in the exponential moving average, it will take, if you go to month 5, it will remove month 1, so that we have month 2 plus month 3 plus month 4 plus month 5. This becomes the average of that quarter. So the advantage of the exponential is that it is up to date, as it were. So that if we were to go to M6, then again we remove month 2, we go to month 3, the number, month 4, month 5, and month 6, then we arrive at the average. So you're basically trying to use the average as a way of forecasting. Now, let's assume you have brought these items into your organization. What are some of the inventory policies that you can have? The first one is what you call the LIFO and the FIFO policy. LIFO and the FIFO policy. LIFO stands for the last item in is the first item out of the store. The FIFO is the first item in is the first item out. Think of it this way. If the expiry of the item is indefinite, in other words, the product does not expire, then LIFO makes sense. Last in can be first out in most cases. But whenever you're dealing with items which have expiry dates, again, bear in mind this effect that we're talking about here. FIFO makes sense. The first item that was in the store becomes the first item out of the store. So you have LIFO and FIFO policies. There is another one which I would recommend you read. It's the ABC model that uses the Pareto principle. So this is it in matching supply and demand. Again, there's a unit for this, but for the basics purposes, I think this should serve. So we go to the next section, which will be looking at the right quality. Thank you.